Today we are going to learn what roots, also called zeros of a function, are and how to find them. So when we have, for example, these four functions, the root of the first function is -2 because the graph intersects the x-axis at -2. The roots of the second function are -1 and -3 because the graph intersects the x-axis at -1 and at -3. The roots of the third function are -1, -2 and -4 because the graph intersects the x-axis at -1, -2 and at -4. And the roots of the fourth function are -1, -2 and -4 because the graph intersects the x-axis at -1 and -2 and it touches the x-axis at -4. So the zeros of a function are the points where the graph of a function crosses or touches the x-axis. Crossing or touching the x-axis means that the y-coordinate is 0. But how can we find the roots of a function when we only have the function equation without the graph itself? We know that the y-coordinate at this point is 0, so the only thing we have to do is to plug in 0 for y and see what x value we get. So plugging in 0 for y, which is basically f of x, gives us 0 equals x plus 2. The next step is to solve for x. We see immediately that x has to be -2 because -2 plus 2 equals 0. So the 0 of this function is -2. Let's look at the second function. Again, we plug in 0 for y, so we get 0 equals x squared plus 4x plus 3. Finding the zeros in this example is not as simple as in the first example, because we have a quadratic equation. Let's see if we can factor this. Which two numbers multiply to 3 and which of the same two numbers add up to 4? Feel free to pause the video and find these two numbers. 3 times 1 equals 3 and 3 plus 1 equals 4. So we can write x plus 1 in parentheses times x plus 3 in parentheses. Now we see immediately that when x equals -1 or when x equals -3, the equation is true. In other words, when x equals -1 or when x equals -3, y equals 0. So the zeros of this quadratic function are -1 and -3. In this example, we saw that we can immediately identify the roots when we have the factored form of a function. So on the other hand, when we have the zeros of a function, the function must be f of x equals x plus 1 in parentheses times x plus 2 in parentheses times x plus 4 in parentheses. And in the fourth example, the function must be f of x equals x plus 1 in parentheses times x plus 2 in parentheses times x plus 4 in parentheses times x plus 4 in parentheses. Note that we have a repeated root here, which is -4. Repeated roots, also called double roots, happen when the graph doesn't cross the x-axis. Instead, it's tangent to the x-axis. At a single root, the graph crosses the x-axis. The tangent to the graph is not horizontal here. Note that in the first example we have a function of degree 1. So we had one root. In the second example we had a function of degree 2. So we had two roots. In the third example we had a function of degree 3. So we had three roots. And in the fourth example we had a function of degree 4. So we had 4 roots. Is this always so, that we have as many roots as many degrees the function has? Feel free to write your answer in the comments. And if you like my videos, like, share and subscribe. Thanks for watching and happy learning everyone.